Hello and welcome back to the course Introduction to Green Process Engineering. In this video, we will talk about a circular bioeconomy. There is an ongoing debate on the sustainability aspects of the bioeconomy. Most stakeholders would interpret the circular bioeconomy as the intersection between the two emerging concepts of the circular economy and the bioeconomy. The European Commission Bioeconomy Strategy interprets the circular bioeconomy as a framework to reduce the dependence on natural resources, transform manufacturing, promote sustainable production of renewable resources from land, fisheries and agriculture, and promote their conversion into various bio-based products and bioenergy while growing new jobs and industries. Looking in the literature about the circularity, bioeconomy and circular bioeconomy, we can see that the number bear testimony to the growing interest in this field of the research. The systematic review brings together 385 publications from 2015 to 2021, originating from 50 countries and appearing in 150 journals, into a coherent account of the status quo of published research on circular bioeconomy. Germany is the leading contributor to the scientific literature based with a contribution of 10%. We should define more precisely what circular bioeconomy really is. Kircher defines the circular economy as an economic system that replaces the end-of-life concept with reducing, alternatively reusing, recycling and recovering materials and production, distribution and consumption processes. Alternatively, a circular bioeconomy is simply interpreted as a more efficient resource management of bio-based renewable resources by integrating circular economy principles into the bioeconomy. The principles of circular bioeconomy are resource efficiency, optimizing value chain over the time, and sustainability. There are various existing and emerging technological pathways to enable the transition of different sectors to circularity for any product supply chain and across the multitude of products in an economy, as shown in the figure on the left. Looking at a concrete example of the agri-food sector, these pathways include scientific developments in digital precision farming and artificial intelligence technologies for crop management, which can reduce nutrition loss on the field, nutrition recovery, and recycling at the end of the field. There are multiple types of application of synthetic biology, gene editing and biotechnology, and advanced fermentation to convert and upcycle agricultural waste and energy crops to plant-based proteins, bioproducts, and bioenergy. Those are substitutes for chemical and fossil energy-based products, as you can see in the figure on the right. These two figures together show the interconnection among the pathways to reduce, recycle, and reuse waste and other biological resources to bioproducts that displace fossil fuels. The common theme across all concepts is a push towards increasing circularity within the economic systems, while the circular bioeconomy also stresses the use of bio-based materials. Independent of the concept, carbon will remain the core molecule that builds fuel, fiber, chemicals, and other products. This implies that the circular bioeconomy is truly a bio-based circular carbon economy. This figure graphically represents the interdependency of the bio-based circular economy's sustainability as a system of systems. This graphic shows the bioeconomy drivers' impact results, in short, DEAR frameworks. Let's summarize it. On the left side are the supply and demand drivers, which determine the development of the bioeconomy. Policies, strategies, and legislation on the top constitute the measures of governments to influence this development. At the bottom, we can see the different resource availabilities for biomass production like land, water, and labor, which influence the biomass market in the center. In the center of the framework are the different suppliers and uses of biomass. Furthermore, waste and byproducts whose usage is the key to a sustainable and circular bioeconomy have been taken into account. In combination, the drivers, policies, and resources have an impact on the demand and supply of the bioeconomy, which in its turn determine to what extent it will contribute to achieving sustainable and policy targets of the objectives pictured on the right-hand side. In this video, we learned about the circular bioeconomy concept, the circular bioeconomy principles, the bio-based circular carbon economy, and the relation within the bioeconomy. We have arrived at the end of this video. Thank you for watching, and I'll see you in the next unit.